In this video, you'll see how to check AWS CloudFormation templates for policy compliance using CloudFormation Guard. With this tool, you can create custom rules for your CloudFormation templates, evaluate the templates for compliance, and fix any non-compliant code. CloudFormation Guard, or CFN Guard, is a command line interface, or CLI, tool that checks AWS CloudFormation templates for policy compliance using a simple policy as code declarative syntax. Let's navigate through the CFN Guard GitHub repository to check the prerequisites and setup instructions. The README provides an overview of the CFN Guard tool and its use cases. Here's a sample CloudFormation template, along with a sample CloudFormation Guard rule set. Here's an example of how to use the CFN Guard binary with the sample template and rule set. Here's how to install the necessary build tools for CloudFormation Guard. You must have Rust installed, as well as a way to run makefiles. For the purposes of this example, these prerequisites have already been installed. Let's copy this git clone command, which will copy the CFN Guard source code locally. To ensure that the compiler is correctly installed, let's first run a command to output the Rust compiler version. The most recent stable Rust compiler is installed. Let's clone the CFN Guard repository to a local folder so we can build and run it on a sample template. Next, let's navigate to the cloned repository so we can begin building the source code into an executable binary. Now you can begin building the CFN Guard tool by running the make command. CFN Guard has finished building, and it has created an output binary for us to run alongside the sample CloudFormation template and rule set file. Let's run the binary with a version flag to ensure that it's been built correctly. The binary has been correctly built, so it can now be used on the sample CloudFormation template. Let's take a look at the template code in Visual Studio. This sample CloudFormation template creates an Amazon Elastic Compute Cloud, or Amazon EC2 instance alongside a security group. For the purposes of this example, let's take a look at a use case scenario in which developers can create ephemeral EC2 development environments using a CloudFormation template to specify cost control and security rules. Let's create a file describing these rules in a syntax compliant with CFN Guard to ensure that the template is checked for compliance whenever the tool runs. Note that CloudFormation Guard focuses on the resources section of the template to ensure resource parameter compliance, but parameters and output compliance rules can also be set. Let's create a rule file that can be passed to CFN Guard to ensure compliance. The file name and extension of the rule file do not need to conform to any specific convention. Let's start by defining a rule for EC2 resource types. This rule checks the template to ensure that the instance type property of defined EC2 resources is set to nano, micro, or small. This rule checks to ensure that the security group ingress property of security groups has its SSH ports set to a non-default value. Here, we define a compliance rule for EC2 volume sizes. Finally, this rule states that EC2 volumes must be specified as encrypted in our template and adds a custom error message. Let's save this rule set file and run the CFN Guard tool. Let's run the CFN Guard binary by specifying its relative path in the repository we cloned earlier. As you can see, CFN Guard picked up 4 compliance errors in our CloudFormation template. We did not, however, receive an error for not specifying the EBS volumes as encrypted because that resource property doesn't exist in the template. To trigger this rule, we can pass the S flag. Passing the S flag gives another linting error corresponding to our custom rule requiring the template to specify EBS volumes as encrypted, along with our custom error message. You can also use flexible syntax within the rules file to define allowed parameters and values. Let's define a variable that contains a list of allowed volume sizes. We'll then reference that variable in the relevant rule. Next, let's return to the template to correct the errors flagged by CFN Guard. Now let's run CFN Guard again. As you can see, we've received no linting errors, indicating that our CloudFormation template is now compliant with our rule set. You've just seen how to check AWS CloudFormation templates for policy compliance using CloudFormation Guard. Thanks for watching. Now it's your turn to try.